What are inverse functions? The inverse of a function has all these same points except that the x values and the y values, they are simply reversed. Suppose we have a function and the function is like this. The points are 1, 0, that is if x is 1, y is 0. If x is minus 3, y is 5. If x is 0, y is 4. So what would be the inverse of the function? We simply replace y by x and x by y. So now this will be 0, 1, x will be 0 and y will be 1, like this. So this is x, this is y now. So 0, 1, 5 minus 3 and 4, 0. This is the inverse of the function. An inverse simply means the opposite or reverse. It is not reciprocal. Please understand, inverse means opposite or reverse, not reciprocal. So the point which has changed, if I represent it by red, so this point has actually gone to this point, that means this location. This point has moved here and this point moved here. So if this is a line which is y equal to x, so these points have changed their position as a mirror, means mirror reflection. So f inverse x, it represents the inverse of a function and we read it as f inverse of x. That means if this is x, what is the inverse of f? This x, we say this is the inverse of x. So how to find the inverse of a function? The function's inverse, we can find it by switching or changing the x and y's on the graph, x to y's and y's to x. If you have an equation, it is the same idea to find the inverse of a function, but there is a specific order to the steps that are needed to do this. The first step is we replace the fx with y. Means if you have fx equal to some function, say x square minus 1, this fx we replace by y. So we say y equal to x square minus 1. Now we switch the x and y's. That is, now this y will be x and this x will be y. If the function is a set of ordered pairs, this is the only step needed. This is the only step which is required. Otherwise, these are the steps. Then we solve by isolating this y. See, this y is already a function of x square minus 1. But now we will find a function where we isolate y like this and then we'll find y in terms of x. And we write the final answer using the inverse notation, that is like this, f inverse x. Let us take an example. We have to find the inverse of our inverse function f inverse x, and this function is 3x minus 5. So we'll start with these steps. First, what we have to do, we have to replace this fx by y. So now this is y, so y equal to 3x minus 5 is the first step. Now we have to replace x with y and y with x. So this y will become x and this x will become y. So this is now the second step. Now we are going to solve for y. How to solve for y? We'll take this phi here, or you can say we can add phi on both the sides. So now this is x plus 5 and this is y. 5 gets cancelled and 5 gets added here. Now we need only y, so we have to divide both the sides by 3. So we divide whole by 3. So we get y equal to x plus 5 by 3. Now this is y in terms of x and this is what we wanted. So y equal to x plus 5 by 3. And now we will replace y, which is actually the inverse of the function, by f inverse x, like this, minus 1. So f inverse x is x plus 5 by 3, this one. We'll take one more example, and because this was a linear function, now this time we'll take a quadratic function. So fx equal to x square plus 3. Now what does this represent? This is representing a parabola, because if you say fx equal to x square, and let us replace it by y equal to x square is simply the equation of a parabola. Now this is a parabola, but now it has 3 added, so it will go up by 3, like this, 3. Now this is our parabola x square plus 3. So as we said, and we know now, that the inverse function is simply the inverse or the replication or reflection with respect to a mirror line, which is y equal to x. So this, when we put a line here, our function is going to become, the inverse will be something like this, right? Now if this is a function, this is not going to be a function. I'll tell you how and what we have to do. We have to put some restrictions. So let us start by the steps, then we'll discuss about this. Fx equal to x square plus 3. We have to replace fx by y, so y equal to x square plus 3. Now what we have to do here is, we have to replace y by x and x by y. Now we have to find y in terms of x. So we'll take 3 here, so it will be x minus 3 equal to y square. Now we'll take the square roots of both the sides. Now when it comes, it becomes y, this y square, and the root is y, and this is plus minus x under root x minus 3. So this is your plus x minus 3, this portion, and this portion is your minus under root x minus 3. So we have two portions here, but we take only this one, f inverse x, because y has to be replaced by f inverse x, x minus 3. Why? See, we have put a restriction here. What is the restriction? The restriction says that x belongs to R, x belongs to the real number, and y belongs to R, that is y belongs to, if this is y belongs to R for all the values which are above 3 or above or equal to 3. See, this under root x minus 3 is only defined, under root is not defined for a negative number. So either x has to be 0, x has to be 3, sorry. So it gives you 0 or more than that. It can be 4 or 5 like this. So x has to be, you can say, right, this value has to be, x has to be greater than equal to 3. So now the f inverse x, we can write that x belongs to R, then x has to be greater than equal to 3. So this is our actual restriction we have put in. So we are only dealing with this part. And this is the domain. What is the range? See, the range can be anything. So y belongs to real number, and y has to be greater than equal to 0, because the result is going to come like this. This is the domain, this is the range. And if you see the domain and range of the actual function, this one, domain was, you can put any value here, x, but the y has to be greater than equal to 3. So this was the restriction for y, right? So this is how the inverse function for the quadratic equation we generally employ. Now we have to find the inverse, f inverse of this under root x plus 4. We'll employ the same technique which we just employed. What we'll do, we'll put hx as y. It can be f(x) or hx, it doesn't matter. So we put y and under root x plus 4. We replace y by x and x by y. Now this becomes x equal to under root y plus 4. We square both the sides, so x square and this square, so under root will go, x square equal to y plus 4. Now we'll find y in terms of x. So y becomes x square minus 4. So y is x square minus 4, which is nothing but the f inverse x, and here it is hx, so it will be h inverse x. So h inverse x is x square minus 4. Now because this is the situation, then again we have to look for the domain and range. The domain is, you can have I'm talking about the inverse. The domain is any value you can put in the domain, means in the place of x, which is greater than or equal to 0, because even if you put any value, it is going to be squared, so it will be always greater than or equal to 0. But when you say this as y equal to x square minus 4, then the y has to be, or y should be greater than or equal to minus 4. Y has to be, because even if it is 0, x is 0, because we have taken the domain as greater than or equal to 0, this is going to be greater than minus 4, because the minimum value of x being squared is 0. So this is minus 4, so y is greater than minus 4. And if you take this one, the actual function, the x has to be greater than or equal to minus 4, because under root of negative is not defined. And when you put any value, this y can be, because under root value will be always greater than or equal to 0, so the range will be greater than or equal to 0 for y. So this is how it is done. Let us take one more example. Find the inverse of fx and determine f inverse x is a function. So we have to find the inverse also, and we have to find out whether the inverse is a function. So this is our 2x square plus 16x plus 29. So what we'll do here is, we'll try to find out, make this as a, okay, and in the perfect square here plus some k, right? We generally say x minus h whole square plus k. So if we can make this, then we're able to solve it easily. So what we have to do here is 2x square plus 16x. Let us take this. We have to take 2 common, because we have to have only one x. So we take 2 common, x square plus 8x. Now we have to make this as a perfect square. So x square plus 8x. What we'll do, we'll take 8, this one, we'll divide it by 2, that will be 4, and we'll square it, that is 16, and this 16 has to be added and subtracted. So this 16 is added, this is 16 is subtracted. So now why we did this? Because this particular x square plus 8x plus 16, if you take this only, this will be x plus 4 whole square. X plus 4 whole square is nothing but x square plus 8x plus 16. So now you you got the perfect square. Now this is remaining, right? 29 is remaining and this number is remaining. So what we'll do, because 2 into 16 is 32. Sorry, 2 into minus 16 is 32. So minus 32 and 29 has to be added. So now y equal to 2 x plus 4 whole square minus 3. Now this is of the form ax minus h whole square plus k. Okay. So this is the form. Now what we can do here is, we can transfer 3 here. So x plus 3. This is 2y plus 4 whole square. Now you can divide it by, say, 2. So you get x plus 3 by 2. Why we are dividing it by 2? We are just trying to eliminate this 2. So y plus 4 whole square is x plus 3 by 2. And now we can take the square roots both the sides. So x plus 3 by 2 is y plus 4 whole square under root. This is going to cancel. And since we know that we always get, when we transfer the square root, we get pi plus minus. So y plus 4, actually this is not square. Y plus 4 gives you plus minus under root x plus 3 by 2. So there are two solutions now. Y plus 4 can be plus x plus 3 by 2 under root, and y plus 4 can be minus under root x plus 3 by 2. So let us transfer this 4 here. So eventually y becomes plus minus under root x plus 3 by 2 minus 4. Okay, when we take this plus minus, so these value, this is simply what? F inverse x. This is f inverse x. So now if you see, if I take half common here from these two, half common here, I get x plus 3 minus of 4. Now the domain of this function was any value you can put in the place of r. So domain is x belongs to r. How about the range? The range, because we know we can write this function like this. So the range, even if this is 0, it will be always greater than or equal to minus 3. So y will be greater than or equal to minus 3. This is the domain and range of this function. But now the case is where we are talking about the f inverse. Now you see that this x, you cannot have a value which is negative here. Okay, so the domain is x belongs to r. Y has to be greater than, this y has to be greater than or equal to -3, or and this y belongs to other range is y can be any number. This is f inverse x. This cannot be this cannot be 0. This is only we need to follow. The cost of renting a car for a day is a flat rate $40 plus charge of this much per kilometer driven. Let R dollars be the total rental cost and D kilometers be the distance driven. Write the function this RD to represent the total cost of a one-day rental. Find the inverse of a function, what does the inverse represent, and give an example of how the inverse could be used. So the function is something like this. The cost of renting a car, this is the flat rate plus this per kilometer. So it will be 0.10 into the distance being covered, RD, this is distance, plus 40 is the flat rate. So this is our function. So this function, R dollars as a function of kilometers here, D is the kilometer, R dollars as a function of D kilometers. So the inverse, R inverse D, which is you can say just dr, because now we are trying to find D kilometers in terms of R dollars. So the function will become the inverse of this function. How to find it? Let us put this as y. So y equal to 0.10x plus 40. See, this is equivalent to y and this is equivalent to x. Now, in order to find the RD, which is actually dr, what we'll do here is we'll replace y by x and x by y. So now we have to find y in terms of x. So we'll take 40 here, x minus 40 divided by 0.10 because we just need y. So y becomes x minus 40 by 0.10, and this is y equal to x minus 40 by 0.10, and this is simply your f inverse x, which is dr, because dr was the inverse we started. So this inverse represents the number of kilometers in terms of dollars as we just indicated. And then the next part is give an example of how the inverse could be used. Now, how much money you had, that means how much dollar you have, you can easily determine how many kilometers you could actually drive. This is the result you can easily achieve. So this is the basic idea about the inverse functions. Thank you so much. Take care of yourself.